for ARC, but as soon as that's sorted, then you'll be hearing a lot more from me through announcements, and I'll be uploading the necessary material as you need. But what I will do in the meantime is I'll put my email address in the chat. So if you want to reach out to me, please feel free to do so. Okay, you got a long session ahead, and I'm not going to take up any more time. But thanks for the opportunity, Nadia. The floor is yours.
Okay, thank you very much. Okay, so today I am going to start the lecture. So let's see if all of my tech stuff works. I also just want to tell you guys, I was in your shoes 2 years ago. So I know your struggles and I know how fun it's also going to be. So we're going to have some fun. Okay, so today I'm going to talk to you about supervised learning and the KNN model. So let's first see what is supervised learning. So supervised learning is also, it's the type of machine learning. But before I get to that, I've skipped my own slide, you guys. So learning unit outcomes. So firstly, we're going to explain the variables in this learning unit and also apply the mathematical concepts. So we're going to build our machine learning model in Excel. Okay, why are we doing this? It's like, it feels pointless, but it's not. It's to show you how it works. So you can see the back end. Like if it breaks, you won't see, oh, okay, it broke. What now? You are going to be able to see, okay, what do I need to fix? Where does it show me what the structure is? What happened? Like, did we have some outlier that completely broke our model? Okay, so this is why we're doing it on Excel so that we can show you what the background is. Okay, then we also, that's why we're going to focus in this session on the KNN, which is the K nearest model, K nearest neighbor model. It's a mouthful. And that is what we're going to do today. So, supervised learning. Machine learning, there's different types. So I don't know if this is zoomed in enough for you guys, but there is like supervised. This first session is like, they gave me so much to read and test. And unsupervised is at least me too, but they did not give you they did not give me answers. Okay, so they gave them a lot of information and not a lot of answers. And then the last one, reinforced learning, is like, you guys are getting data, I make my own books. So the thing is, he is completely doing everything on its own. He's reading, he's testing everything. Okay, so we are luckily going to start with supervised learning. Why? Because it's it's more controllable. So let's see. Supervised learning can be classified or into classification and regression. So it's a split with classification and regression. With classification, we have a lot of different models, and with regression, and we're going to see what the difference is. What does it mean? Why would we choose each one? Okay, so let's see what the difference is. Classification, so we have a predefined list of what it can be. So we have an answer. So we have an answer. We know, okay, if this happens, it's a yes. So if you get an email from somewhere in India that you have never heard of and has not subscribed to anything, you would know it's spam, right? Or at least you would think it's spam. Why do I choose India? Because I couldn't think of another country. Regression. So this is going to be more of the answer's not there, but you can predict it. So you can predict what's going to happen. So what's going to happen is with a baby, the baby is going to grow up to a toddler, and the toddler is going to grow up to a child, and then the child is going to become adult, and then into old age. So you can predict it. It's a linear, predictive outcome. Okay, so that's why we have classification and regression. Classification, just a note on that one, is also more categorical. So you have a certain age group. It's like teenagers, That's enough said, right? So teenagers is on a group on their own, and toddlers is a group on their own as well. Toddlers making a mess, don't understand what they're doing, but they're carrying on with life. Teenagers testing boundaries. Okay, so they're a bit more risky, so we're going to not mess with them. Okay, so why did I talk about categories? And why did I talk about the income and the age? So those are our variables. The variables is what we use to train our data. So our data is trained on variables, and it can be qualitative, which is usually discrete or categorical. So you have, in this case, we have flower. So we have the iris flower, and there are 3 different types. So we have 3 different types of iris flower, and we're going to put them in a category. So we have the setosa as a category, the versicolor as a category, and the virginica as a category. So that is your categories. It's discrete. What does it mean to be discrete? It is identifiable. Okay, so it's 1, 2, 3. Okay, so you can count it. It's countable and it's categorical. Quantitative data, on the other hand, that is data that has bit more complexity to it. So it's the temperature. The temperature, we don't really have a 0 temperature, or it doesn't really exist, because 0 is near freezing point, but it just doesn't disappear, right? It's still a temperature. So 0 is still a temperature, and so it has a bit more complexity to it. Pressure, fuel rate, prices, everything, that is more quantitative data. So we still use that data, and that is also used for making predictions. So making predictions, helping us figure out what has an influence on our categorical data or on our outcome. So some of our outcomes also is then for the categorical data changed. We're going to get to that now. Okay, so for the categorical data, this is where we're going to change it. So we have categorical data that can be ordered. So in this case, it's a Starbucks. We have a short, tall, grande, and venti. So we have small, medium, large, and extra large. Okay, so we have an order. You can rank it. Okay, so it's ordinal, ordered, ordinal. Okay, for the dummy variables, why do we need this? So we can't really go and tell a machine or the computer, okay, short, tall, grande, venti. It's not going to understand that. So we give it a symbol. In this case, the symbol is a number. So we're going to give it 0, 1, 2, 3. So that's our dummy variables. We're substituting it in so that we are able to reference it. We can point back to, okay, 0 was a short. Okay, so why do we start with 0? We start with 0 because in computers, they don't start with 1. 1 is the second place. So we start with 0. Every time we start counting as well, we start with a 0. Okay, so that is just important to remember sometimes, because sometimes we have 4 variables and there is, then you have the number 2, 3. It's like, but we have 4. Okay, but we start counting at 0. Okay, so that's why it sometimes can be a bit confusing, but it is very quick to pick up. Okay. So then we have nominal categorical data. So that is, you can number it. It's like you can number it, you can count it. So you can count the number of cars on the road that's driving past your house. Okay, or you can count how many jelly beans you ate. Okay, so it's very easy to count it. It's countable. You can see the breakfast menu. You can count how many items there are on the breakfast menu. So it's not ordered, but it's countable. Okay, so it's targets. So it's still, you can count it. So how to sum it up, we can have nominal data, which is, and which can be categorical. Ordinal data It is ordered, so it has a rank order, and it can be a category as well. Remember, because it can be first place, second place, third place. We have interval data. That is actually data more like the temperatures. So the temperatures, you're going to have a sunny day, so it's going to be between 18 and 35 degrees Celsius, right? So that's an interval of data. And that's why it's equal spacing usually, because you want to make sure that you have enough data in the right sequence, because we work with groups of data. So if you group teenagers and toddlers in the same group, it's not going to work. Okay. It's also going to be chaos. So let's make sure that the groups are separate but still equally spaced. So the ages are equally spaced. Okay, and then the ratio is when there is a true zero. So there is a true zero with banking, because if you have zero rand, you have no money. Okay, so there's a true zero. That is the easiest one I can explain that one with. Okay, so for the encoding or the dummy variables, you're going to encode it. So you're going to say, in this case, the quality of air. If it's fair, it is 0. If it's good, it is 1. And if it's really, really good, it's 2. Okay. But in some data sets, there could be a negative, a bad. So then the bad would be 0, fair would be 1, good will be 2, and premium will be 3. Okay, so you just adjust your encoding or your dummy variables as you have your categories, or as you see what categories you have or what is needed. Okay, everybody still with me? Thumbs up, thumbs down. Okay, goodness. Thumbs up. I don't think there's thumbs down, but there is a scared or surprised emoji. Okay, so now how do we use this? How do we use everything we know? So we're going to apply it to the KNN, which is the K nearest neighbors model. So this is a supervised learning model. And we have a few steps. So I'm actually going to show you these few steps today as well on an Excel spreadsheet. I'm also going to share the Excel spreadsheet and the slideshow on ARC for you guys, so don't worry, you can go look at it again. Okay, so first we are going to load the data. I am actually not going to tell you this because I'm going to show it to you. So let's carry on. I'm going to show you how to do it. So we have some data here. I'm not sure you're going to see it very nicely, but I'm going to show you it in the Excel spreadsheet as well. So we're going to look at the petal length and width, as well as the sepal length and width. That's like the bigger petal on the flower. Okay, so what do? We're going to get our data. That is our data set. We have a data set, and it is going to be used to plot the data. Okay, but first, for the K nearest neighbors, we are going to use some mathematics. Okay, so we're going to calculate the Euclidean distance. Don't worry, guys, you do not have to memorize this. We're going to do practical stuff, so you're going to use it in your projects and your assignments. You don't have to go and memorize it. So we're going to calculate the Euclidean distance. So everybody learned about Pythagoras in high school, right? If not, we'll quickly cover it now. Okay, so Pythagoras is to get the nearest distance between 2 points. Okay, and it's a squared plus b squared is equal to c squared. But c squared, that is the quickest way to get from point A to point B. Okay, so point A, when you guys have to go around the block, you can't do as C does sometimes, because sometimes there's a building in the way. Okay, so we can't always use C, but we can use it in data science to see what is approximately, or what's the closest as the crow flies. So what the distance is between the two. Okay, and we have a slope. Everybody learned what a slope is. So the slope is how fast that line goes up or down. Okay, so it's the slope is the y values. So it's the distance of y over the distance of x. So the y, can I have a cursor? Oh, I can have a laser pointer. Oh, this is so nice. Okay, so we can get the distance of the y's over the distance of x. Yes, guys, I'm still learning as well. To get the slope of of the line. Okay, if we flip it, then we're going this slope. So the distance between A and B is going to be our Euclidean distance. Okay, so we are going to see. Now we're going to do it. So at point A, we have 6 and a 4. So x is 6 and y is equals to 4. So we're going to substitute in. So it is 6 minus, which is x1 minus x2, which is the x at B, plus 4, which is y at A, minus 3, y at B. And that is our calculation. So in the end, we have the Euclidean distance of 3.16. Okay, so this is how we're going to calculate. I'm going to show you now where we're going to use it. So for the last slide, before we go to the Excel and the practical side of this, we actually have some links that you guys can go and look at as well. Yes, Utamaleng or Utemeleng.
Yeah, no, you do me. I think you often get the name right the first time, and then, yeah,
Okay, sorry.
for a lot of us, yeah. I just wanted to ask, maybe I might be jumping the gun here on this one. Is this K means clustering? It's part of unsupervised
Yes,
learning.
it is. It's part of it. Yes, that the KNN is part of the clustering. We are clustering. That is correct. You picked on it
Oh,
quite quickly. Nice.
okay, okay.
Well done. Okay, yes, Nazarene.
Hi, ma'am. Since we're working with Pythagoras, I just wanted to confirm in stats, will we only be working with right angle triangles, as that is what Pythag is linked to, or will we be working with different types of other triangles?
Honestly, I actually just showed you guys this one to let you know where the Euclidean distance come from. So we're actually mostly going to use the formulas and not actual triangles. But it's a good question. We're not really working with the triangles. We're working with the distance, which is going to be our grouping. So I'm going to show you now. I quickly need to go to my Excel and open that for you so that we can carry on. Okay, there we go. Okay. Okay, so this is our Excel. This is where we're going to use that. So we're going to use that with our data. So I'm firstly going to just show you the data and how to plot it. So I am going to share this with you. Don't worry. And I'm quickly going to also show you how we're going to use the Euclidean distance. So first of all, I want to insert a correlation matrix or scatter plot. So I want to see the correlation between the sepal width, so the petal length and the petal width. Okay, so this is the big petal. So we're going to have the big petal and the small petal, and we're going to see what the difference is and how we can group it. So that is also what the Euclidean distance is for. We want to see how far away the points are from each other. Okay, so how do we add some data to this? So I think we're going to add some data. There we go. Going to make my, this is going to be the iris flower. There's a lot of different ways to do this. I'm just showing one way. There is many different ways. Okay, so we have X as the width and Y as the length. Okay, so if I say okay to this and add it, it should show up here. Okay, perfect. So we already have at least our chart title. Now I want to see what is actually going on. So I want my data labels. But you can see it's a bit grouped. It's grouped, but we can't really see the group. So let's change a bit of the spaces. Okay, so you guys can also going to do this on your own. Or if you want, you can also ask the tutors that so that they can help you. Okay, so I want to make it a bit bigger. So let's start with X. So the X axis. I am going to change the minimum to be at 2 because there's just a bunch of open space there. It's not going to give us any insight. Okay, so that makes it a bit more spread out, but let's change axis Y as well because we want to actually see what's happening. And I'm going to change it to, let's say 4.5. I think 4.5 is a good one. 4.5. Okay, so there we go, that changed. So now we can see, oh, there's a few things that's happening. But we can't really see which flower it is. So how do we change that? I'm going to click on it, click on the number. You're going to go to the format data tables. You're going to change it from the Y and X value to the series name, or the Y value. There we go. Value from cells. There we go. And you select your species. Okay, and you say okay, and now it's going to show you the different species. Okay, so now that we have plotted it, I also want to add this little new observation. So how do I add this new observation? I add data. So you can either click on here or you can say select data. You're going to add the new observation, which is going to be the width on X and Y is going to be the length. Okay, so remember which you made which. If you can't remember, you can, oh no. What happened? What happened? Let's just do it again. Okay, plot my new little plot and it should show up now. And it doesn't. Why is this doing it? Okay, there we go. Something just mixed it. So if that happens, I apparently just needed to give it enough time. Okay, so this is our new points. And how are we going to use the Euclidean distance? We're going to see what the distance is between the points. Okay, because we want to see where does this one fit in. But I'm going to first, let's draw some things. Okay, so the Virginicas. There is a group of Virginicas. We have some a lost Virginica over here, a lost Virginica flower over here, and then we have the Setosas. Let's make the Setosa purple. That is this cluster or grouping. And we have, let's say green. I like green. There we go. We have versicolor in this cluster. Okay, so it is grouping it together. So we want to see this point. Where does this this flower belong? What are we going to predict it to be? So we are going to see the average, which one it's closest to. Okay, is it closest to the Virginica, the versicolor, or the Setosa? That's why we are grouping it together. Okay, there we go. I almost didn't see if you guys had some hands up. So then we're going to see which is the closest. That's where we use this Euclidean distance. Okay, because we have the values and we're going to now make it easier. Yes, Curtly.
Good evening. I just wanted to know the value of K. Is it always going to be given, or do we have a mathematic formula that we could use to get K? Should we not be given K, or is it always something that will be given? I did read that it said that when you choose K, um, it you would most likely would have to choose between um, somewhere I read that it's going to be the square root of n, where n is the number of values. And somewhere else it just says that you would have to put in the number of k until it balances your bias and your variance. So I don't really know what should one do when you have to choose your number of k.
Okay.
Thank you.
That is a very good question. Usually we actually go through a variety of Ks. So we want it to be not too big, also not too small. In this case, it was 3 because we thought there's 3 flowers. Let's make it 3 different groups, but it can be increased or decreased. So we start off somewhere where we think it's a good place to start, and then we go up and down to see the bias and variance, to see which one has the most accurate answers. So that's also data science. We play around. We see, okay, this is k is equals to 3 for this one, is amazing. But if we do k equals to 9, it could be even better. But if we do k equals to 1, it's not going to really tell us anything because there's just one group there. Okay, so it's just splitting it up and making it more complex. So the more complex the data, the higher the value of k usually becomes. I think it was Itimaleng and then Nazreen.
Okay, cool. Thanks a lot again. Um, I suppose obviously, going back to the old discussions about K, overall, it's normally the number of observations. I think here we're looking at 15 of them over 2. So the square root of 15 over 2 here would be the number of would be the value for K. So obviously this is, we're in the beginning of a lot of these sessions, so I would imagine this is a bit more simplified view of that. I suppose that's
Yes.
also I suppose that also does introduce the next question that I would have, which is to say, prior to us introducing the Euclidean point, would it not been a bit more safer to first calculate our number of well, maybe let me say our K number first, so that we can understand obviously where some of this where we can get the correct Euclidean number. It is obviously can get a bit more unnecessarily complicated if first and foremost we were to, for example, now start introducing, elbow methods or silhouette methods, for example. But I just wanted to see from a step perspective, would it not be more important first to understand how many observations do we have to establish our K number, and then the next step be, let's first devise the distances that we've established between all of these observations. I think the last question that I do have also, as far as the clustering is concerned, obviously it is possible to have quite a number of subgroups involved into all of this. I do see that as far as the Virginica one can form part of a subgroup that's a whole cluster that's in versicolor, for example. But is there a much more different approach to how we're clustering these 3 in particular? Or obviously right now we're just taking the most easy to comprehend approach. As in maybe we
Um,
don't, this is a much more simplified view. We don't want to complicate it.
So yes, we are doing a much more simplified view so that we can just get the basics down, because later on you are going to use the elbow method, which is very nice, but you're going to use it in Python. So this is not this subject. This is the next subject for, it's going to be Python programming for data analytics. And there you're going to use the elbow method to see which K you're actually going to use. So this one is just to actually show you where it comes from. And if I go to our next sheet, this is actually also where we're going to get all of the Euclidean distances. We're going to get the ranks and we're going to label it. So this is where we are going to do all of that to be able to, I'm just showing you here the plotting of the data. So you can see, okay, no, it is in groups. There is some groups, and that is why we're also looking at groups. So the grouping of the flowers. Okay, I hope that answered your question.
Yes, I think it is.
Okay.
Obviously, it would take quite a lot of work for us to know that, to be on Python just to get the K number or just the Euclidean distance.
Yeah. So in Python, it's much easier. So that's why I'm making it. This is also an easier example, because if you take a large data set, this is going to take forever. And I just want to show you how it works in the background. Okay. Okay. I hope that answered into Maleng. So Nazreen, did you have a question or did we answer it?
Ma'am, I just wanted to know, like, to make like life easier, like looking at your new page, I've seen you use like Excel functions. So in regards to calculations, when we are like providing our calculations for the specific modules, are we allowed to like use Excel functions and formulas in the regard of calculations?
Yes, you are. It's like I'm going to
Thank
show
you.
you now how to use it, and we're going to use it. We're not going to sit here with a calculator. We are data
Okay,
scientists. We are not preschool kids, right? Okay. So
thank
we're
you.
going to use calculus. We're not going to just make it look pretty. That is going to make your life much harder. So we don't want to make your life harder. We're going to make it easier. But it is going to be just showing you the background. So it's still not as easy as Python, but Python can also become quite challenging. So let's start with this, which is going to be our calculations. So if you do all of these calculations, you are going, this is what you're going to use as well in your POEs. Your POEs is projects or your assessment, your formative assessments, and you are going to get the data. You're going, and then you can go and make this for yourself. You can go and make the Euclidean distance, rank, and label, the K values, the new observation, and what it is going to, and your outcome as well. So we're going to work through it. So let's start. So firstly, we have your length and width. We're going to focus one at a time. So let's first start with the first one. So let's do the Euclidean distance of one flower. So we are going to subtract 5. We're going to subtract. Okay, this is actually a different flower. I forgot where that flower is. But let's do one flower and then we're going to apply it here, which is going to help us. So firstly, do one flower. So we have the length and the width. The length is going to be 5.3. So it's 5.3. It's going to be equals to 5.3 minus 5.2. So this is the length of the two flowers. Then we get the difference. So we're going to have the square root. So we are going to use the Excel functions. So square root, and we're just going to use that number that we previously got. Then we're going to have the next section, which is the width of the two flowers. It's going to be 3.7 minus 3.1. And we're going to also get the square root of the difference. So that is it. Now you can add your two square roots together. So we're going to add these two numbers together. Okay, just remember to get the right number. And then you get the square root. I will already put that in. So that is going to be your Euclidean distance. So instead of doing that for every single one, we have it here as well. So we're going to use our functions. So we have a square root. Oh, no, we have a square root, and we have the two, we're going to have some extra bracket because we have the length of the number as well as the observation. So this is what we are comparing it to, the new observation compared to all of the old historical data. Okay, so we have the length minus the length. Okay, so this is a very quick and neat trick. So we say F4. Okay, so on your keyboard, there's an F4 sign. So it's going to give it $signs so that that one is locked in. So that one's not going to move. That one's going to stay there. So the A8, that one will change, but the observation will be locked in place. Okay, then we have, oh, I calculated it wrong here. Okay. Oh, no. Okay. Then we square it. Okay. Then it's that one, the little cap squared, and then we are going to get the width. Okay, so the width is going to be the width of the old observation minus the width of the new observation. Yes, Kirtley, I did make a mistake.
Yes, that's what I was calling. I raised my
I made
hand
a
for that.
mistake.
Yeah.
Yeah, but thank you for picking it up. Okay, so the difference squared. That is going to make a difference to our answers. And so it's not square root, it's squaring it. See, sometimes we also make mistakes. And that one is the square root. So that's a big difference. So that is what we did here. Now, I am not going to type that out every time. So I'm going to go and drag it. Okay, so as you can see, it populates on its own, and the observation is still there, but the flower you're looking at changed. Okay, so that is a very nice one to look at. The label is going to stay exactly the same. So you can literally copy paste because we're working with that flower with the new, we're getting the distance of this flower, the old flower to the new flower. So this is just a copy paste, but you can just take out the fill. Okay, so you don't have to have it colored. So that is how you get the Euclidean distance of every single flower according to the new observation. Now, how are we going to use that? We're going to rank it. Okay, so we want to see which one is first. Okay, so ranking it, gonna say rank. So we're going to use our Excel functions. We are going to rank it, and we have all of our numbers here. Oh, there we go. F8, oh wait, it's the number just next to it. So we want to see what rank it is according to the whole list. Okay, and then order, we are going to say ascending. So ascending order, close your brackets, enter. Okay, so the first flower is of rank 3. We want to find the first one. Okay, so there is the first flower, well, rank 1. So this is the closest flower to our new observation. Okay, so K values we can look at to see where it falls. Okay, so we're going to use VLOOKUP. Ooh, VLOOKUP. No, don't do that. Okay, yes, Ulrich.
I think you need to update your formula, the ranking formula. You didn't fix the column F.
Didn't I fix the column F? Oh, well done. Well done for seeing that. Because it moved down. See, we all make mistakes. Thank you very much. So F4, fixing it. And now we can go. Okay, luckily number one still number one, but that does make a difference. Thank you very much for seeing that. Okay, so let me try and not make a mess of the others. VLOOKUP. So we're going to look for number one, so rank one inside. Inside, let's just comma point inside the ranking. There we go. And we're going to F4 it. It has to be 4. Then we're going to look at the third column, third one. Oh wait, I did not choose all of it. Oh, that's what my problem. You need to choose all of it. There we go. And F4, we're going to look for the column index number. We're going to look at 3. We want to see what the label is for, so 3, and then we're going to say false for the range lookup. There we go. Oh, something happened. The lookup value, we want to look up number 1, table array, column index. Oh, okay, comma point. Okay, so that's what I missed. So it had to be a false because we want an exact match. There we go. So first, the first 3 values are setosas. Okay, so the first 3 flowers closest to the new observation are the setosa flowers. Okay, so that is, you can also see what it is there. Okay, so this is the mode. The K value is 1, which is then the same as this. So I'm just going to copy and paste it. Make sure everything is still fine. And then we're going to populate it. So the setosa, let's say the setosa is, we didn't actually give the flowers numbers yet. So what do we say? Setosa is 0 or setosa is 1? Let's say setosa is 1. You guys can choose this. So encoding is you choose actually which category you want to number what. Okay. Versicolor, let's make versicolor 0 and Virginica 2. Okay, so setosa is 1, versicolor, that is 0, 1 and 0. Okay, so the mode is 1. All of the K values or the labels, which is the first 9, which is the closest to the new observation. The mode is setosa, so we're going to say that new observation is going to be a setosa. So we predict it to be a setosa. It can change, but we're going to predict it to be a setosa. Okay. So this is your KNN. There is also, here's the more explanations and some other values. We just changed the values, and then you can try. You can go and try, see what the new observation, what the K values is, what the rank, distance, and label is. And there's also a data set. So another data set you can train on, which is going to be if it is a cancer or not a cancer. Okay, so it's a tumor data set, and you guys can go play around with that. So do you guys have any questions on this? Because there is a KNN model that you're going to build on Excel in your formative assessment 2, I think. So are you guys okay still? Can I see some faces? Ah, Alizwe? Sorry, I didn't see your hand previously.
No stress. I just wanted to ask, for the VLOOKUP, what does the 3 and the false represent?
Oh, okay, so the 3, let me quickly open it. So the VLOOKUP, the 3 represents you're looking at the third columns. So this is column 1, this is column 2. You're looking at the third column, you're looking at the label column. You want to see what the label is. Okay, and false is it's going to be an exact match. True is not an exact match. For this case, it is false, which is an exact match. So this is the lookup. It has to be the rank, has to be an exact match to the K value to give you back your the label. Okay, does that make sense?
That's perfect. Thank you so much.
Okay, perfect. Any other questions? So in this case, we're going to predict it to be Setosa. Yes, oh, the hand went down. Okay, so this is actually quite a short lesson, but it's a good start, I think. Are you guys are not afraid? We didn't scare you off, right? Okay. You're all there still? Can't see you guys. Okay. You're still there. Great. How are you feeling about this subject? It's not that hard. Oh, no, we have a surprise face. Okay, yes. Come, Mojelo.
Good evening, everyone. I feel like it's a lot better since it's on Excel. I don't know.
Okay.
Written format of this subject might have been harder.
Oh, yes. No, I don't think it's actually yeah, I don't know how you're going to do that. That's going to take a lot of time. It's
Yeah,
doable. It's doable. It's just going to take a lot of time.
yeah.
But yes. Okay.
And then I wanted to also ask, will this be available like tomorrow, or when will this be available?
I'm going to upload
This
it now.
Okay.
I'm going to
All right,
upload
thank
it
you.
now after we had this class. I'm going
Yeah,
to save what we did and upload it so that you guys can have the end one.
thank you. Thank you. Appreciate that.
Yes, BSM. I can't see your name. It's just that. B,
Hi
yes.
everyone. Hi. I just wanted to ask for this module, can we use the textbook or should we rely on just the lectures and module outline?
I would recommend you use the textbook because you have theory. So the theory part of this module is you're going to have to research a bit. So it's not going to be a lot of theory, but it is still necessary. So we are going to have some theory questions in our assessments, and we would like you to please use your handbooks. Other materials are welcome as well. We just want you guys to start referencing, start using the tools that's available and reference correctly. Please note, this is very important. AI is not a reference. Okay, so you can use AI to find your articles or your websites. Okay, but please don't quote AI. It's not accurate. If you're going to, when you're going to start coding, you'll see it's not very reliable. Okay, so it's good to actually go and see the handbook, or if you can get an online version as well, just to read through it, especially for those questions. And most of the questions we want you to answer is up on ARC. So we have some activities there that you can go and ask that and answer that questions for yourself. You can upload it as well, and we can mark it as we go along so that you can see where you're at and if you're on track. Any more questions? We at least took an hour for this session. So we did put in more time for these sessions because sometimes we do have more to teach you. In this case, it's still the beginning, so we won't bombard you too much. But yes, Tando.
Nadia, I just wanted to ask if there are any ICE tasks for this module.
Yes. We do have ICE tasks. We haven't uploaded it yet, but we do have ICE tasks, and we will let you know when it's available and when you can do it. Okay, we're not going to have it in this week or next week, but we'll have it up in March. Okay. ICE task also counts 10% of your overall mark, so it's important to actually go and do it. But we'll let you know and make sure you're up to date on that as well. Oh, did I miss a few questions here in the chat? Okay. No, okay. So, as for the study partners, you are each other's study partners. We're going to make a group. You can have discussions in your sessions, in your tutorial sessions. That's tutorial, and we can also there is discussion points. There's on ARC, there's a discussion forum where you can ask your questions. You can collaborate with each other. You can talk to each other. Okay. Bianca took her hand down. Kodani?
Thank you. I just wanted to ask a question around the study material. I searched for it online. I did find a PDF. I'm just not sure if it's up to date. There's a PDF on GitHub. I just wanted you to confirm if that's we can use that material or not, because it seems like it does. It is the full book on PDF. I'm not sure if we can use that.
That is nice. If you have it, share it. But I did not say that. In any case, yes, you can have. You can. You can also. You can share it in the chat if you can, and we can just have a look to see if it is the correct one. I don't think I have a PDF version, but if you go and look at the title, it should be also show you an indication. The handbook is not going to change. Okay.
Okay. I dropped it on the chats. Please
Thank
confirm.
you. Let me
Sure.
quickly have a look there. Oh, okay. I just needed to download first. Ah, there we go. Yes, that's the one. That is perfect. That is the handbook. You can use it. Antani? Oh no. Anati.
All right. You just gave me a
Sorry.
new name.
Sorry about
Good,
that.
good evening, everyone. I just wanted to confirm if the referencing style is Harvard.
Yes. The referencing style is mostly Harvard. We do have referencing courses as well, and you will have referencing sessions because we have sometimes it changes year to year. So I'm not sure about this year, but we will upload your referencing guidelines as well. They also have referencing classes, usually on a Wednesday. It's on your past document. You on your timetable, there should be a library session, which is going to show you the referencing, and also on the library site. So the referencing will be there. If you do struggle with that, you can actually go to the library and ask them. It's like, help, I'm drowning. Is my referencing okay? So, but don't go and let them reference it for you. Do some referencing and then ask them some help. Okay.
Okay.
Simpiwe.
Thanks, Nadia. Just a comment and a question. A comment is probably I have to watch this again, and I'm hoping there is some online tutorials. I guess I'm a bit slower than my other counterpart. And then the question is, you mentioned that the KNN, you can achieve it in different ways. For example, now using Excel, I think you also touched on Python to say you can also use Python. Just trying to understand in in terms of real world in production, what is the most prominent? Do you see Excel being used a lot, or might it be Python? I'm thinking it's Python, but I just want to get your view around that.
So in practice, it's usually Python and R. So you're not going to work with R, but Python is used in a lot of practices, especially for this. We're just showing you the background of it so that you understand what you're going to be doing in Python. Okay. I hope that helps. Okay. For Tamika. So it is it accurate? This model is accurate for this scenario. It's actually not a lot of data. We would need a lot more data to make it accurate. But for giving you examples of how it works, it's a very good example because you can see it, you can visualize it. So the Euclidean distance, so I'm going to say you can work it out. I would say if you did a few more new types of flowers and you see if it is actually that flower, you can go and see yes or no if it was the flower and work out a percentage of how accurate it was. Okay. Yes, you have tutors for this module, and I am also going to help there. We are still busy hiring the tutors, but they will be available weekly for you, and we will have group sessions. So unfortunately, because we're such a large group, we can't have individual sessions, but we can have different sessions in the week, and you can join any session that you want. Also, on the previous note, we will be uploading these videos to YouTube and sending you the link, as well as having it uploaded to ARC. So you can go and listen to it again and try it on your own. We will have a WhatsApp group. I just need to get the link to that WhatsApp group. Okay, we will create one and send it out. How do you join the tutoring? We will also send the links out on ARC, and it will probably be on Teams, so it will be a team session. Okay. We will also add it to your calendar and ARC, and we will get those links fixed. Okay. So that is all that I have to say, I think, for today. I hope I answered most of your questions. All of them, hopefully all of them. So I'm going to stop the recording. So I will upload the recording